Good morning. Well, I am not with you this morning, but we're going to continue our lessons through this video lecture today that I have recorded especially for you. Up until this point, we've covered some pretty important topics. We started with dealing with positive and negative numbers. We dealt with what is a function. We dealt with graphing inequalities and talking about inequalities. We talked about our distribution property. We talked about all these different things. We've begun to talk about linear functions. We talked yesterday about independent variables, dependent variables, what depends on what, and how we solve them. Today we're going to deal with linear functions, and we're going to start off by graphing linear functions. So given the following x values, find the corresponding y values. So we're given the function that f of x equals 2x plus 3. Remember, we learned this yesterday, we call this our domain, and we call our y values our range. So our domain is -5, -4, -1, 0, 1, and 3 respectively. So what I'm going to basically do is I'm going to plug in here in my chart -5, -4, -1, 0, 1, and 3. Now in each of these I need to do some basic arithmetic. So I have 2, I plug each one in just like we learned to do yesterday. Times -5 plus 3. When I solve that out, that gives me -10 plus 3, which gives me -7. So my first set of coordinates is at -5, -7. My next one, I'm going to do 2 times -4, make sure you're taking notes as I go along, plus 3. That gives me -8 plus 3, which gives me -5. So I have -4 and -5. Plug in -1. We're going to do this for each one of these. That gives me -2 plus 3, which gives me 1. Plug in a 0. 2 times 0 plus 3. Well, obviously, 0 times anything is 0. So my coordinate is, for y, is 3. Next, 2 times 1 plus 3. That gives me 2 plus 3, which is 5. 2 times 3 plus 3 gives me 6 plus 3, which is 9. Let's finish writing these points over here in my T-chart. Remember, we talked about these yesterday. 0 and 3, 1 and 5, 3 and 9. So my domain includes the values. Remember, this is my x values. Range is my y. So my domain includes the values -5, -4, 0, 1, and 3. My range contains the values -7, -5, 3, 5, and 9. In order to graph the function then, one of the most basic ways to do that is to simply plot my points. So I'm going to go with each point. I'm going to go over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6, 7. Plot these with me as I go along. Go -4, down 1, 2, 3, 4, 5. Go over 0 and up 1, 2, 3. Go over 1 and up 1, 2, 3, 4, 5. And go over 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I've done my job right, I should be able to draw a straight line through all of my points. And yep, there, sure enough, there's my straight line. Now, because it's not a closed line, I'm going to put arrows on either side, and that tells me that, hey, I've just built a continuous line out of a set of plots. Now, what's cool is we not only had the set of plots so we could see that relationship, but we also had then the function itself, 2x plus 3, so we could see that relationship as well as we went along. Okay, let's go forward. We're going to do this again. Now we have g of x equals 1/2 x plus 2. My x values, -8, -4, 0, 2, 6, and 8. What I'd like you to do is, teacher, please pause the recording and give them a chance to solve out for y on their own. Give them a few moments. Once you're ready, press play. Okay, demonstrating then, as we go forward, we have 1/2 times -8 plus 2, which gives me -4 plus 2, which gives me -2. 1/2 times -4 plus 2 gives me -2 plus 2, which gives me 0. 1/2 times 0 plus 2, 0 plus 2 is just simply 2. 1/2 times 2 plus 2 gives me 1 plus 2. 1 plus 2 is 3. Hopefully you remember that problem from kindergarten. 1/2 times 6 plus 2 gives me 3 plus 2, which gives me 5. And finally, half of 8 plus 2 gives me 4 plus 2, which gives me 7. Let's fill in our t-chart over here. Some people also call this a table, just depends on your preference of terminology. So I have 8 and -2, or -8 and -2, excuse me, -4 and 0, 0 and 2, 2 and 3, 6 and 5, and 8 and 7. So my domain here is going to follow with the function and all the x values. So I have -8, -4, 0, 2, 6, and 8. I have -2 for the range, 0, 2, 3, 5, and 7. Okay? To graph the plot, or to graph this function, we're going to go step by step, and we're going to plot every point. So let's start at the top. -8, I go over 1, 2, 3, 4, 5, 6, 7, 8, down 2. -4, 1, 2, 3, 4, over 0. 0, 2, 2, 3, over 6, 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5, and 8, and up 1, 2, 3, 4, 5, 6, 7. Once again, because this is a linear means line, I've got a straight line that is going through all of my plots. So go ahead and draw your straight line in there. Bada bing, bada boom. All right, make sure you've got all that copied down, and let's move forward. Whoop, too far. Whoop. All right, our next topic, we'll skip a few sections and go on to slope as a rate of change. Make sure that's where I'm supposed to be. Yes. Slope as a rate of change. So we've talked about this. You've learned this in Algebra 1. You've already had this concept before. When you go to geometry, we're going to talk about slope. When we go into, probably if you were to go back to pre-algebra, they would talk about slope. But slope is, the definition here is the rate of vertical change to horizontal change. We also call this, whoops, we call this rise over run. So my slope, basically, the rate of vertical change, so how much am I going up or down with compared to how much am I going left to right? Okay? We would also call this any type of constant rate if we're dealing with a practical problem. Now, reading from the graph left to right, they've given us a few examples. We have 4 examples of slopes here. A positive slope goes from the bottom left to upper right. The negative slope goes from upper left to bottom right. Zero slope is a straight horizontal line, and no slope, not zero slope, but no slope, simply is a straight line. It's important to note that if you have no slope, you do not have a function. Remember, we talked about that yesterday, that the vertical line test, if you were paying attention. So find the slope between each given point. So between C and D, I look at this from C to D, draw that little line in there, and I'm going down 3 and over 3. So I go down 3, and then I go 3 to the right. That means reduce my fraction. 3 divided by 3 is 1, so I have -1. And that makes sense that I would have a negative slope because look at the direction of the line. Let's go between B and C. Draw my line in here. I can tell already from looking at it, I'm going to have a positive slope. So I'm going up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So my slope is 3 over 6. My rise over my run. That gets me to 1/2. Now E to F is a no slope problem. Because look, I can't go over to the right any. If I have slope, I have to have a horizontal change. So what I've got is I've got a slope that technically has a 0 in the denominator and goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've got a slope that goes up 13. That's my rise, but it goes over 0. That is a no slope solution. Is that a function? No. If you had a line drawn between E and F and you tried to tell me that was a function, they would slap you with the wet fish. Any good math teacher would. That's just the ways of the force. Okay? Now, from A to E. A to E is a much longer slope. Notice how flat this slope will be. There's a little principle we can learn here. The flatter the slope, the bigger the fraction it is. The steeper the slope, the bigger a whole number it is. So look, I go up 1, my rise is 1, and I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a 1 over 12 slope. Rise 1, run 12. It's positive. It is a very, very, not a steep slope, it's a very flat slope. Between B and D, okay, I have 0 rise, and I have a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. That reduces to 0, so I have a 0 slope solution. That's basically a straight line. And between B and F, I go from B to F, draw that line in there. And so I'm going, kind of helps when you're in a problem like this to sort of draw where the middle point is down here at the bottom, as I've just done. So I'm going down 1, 2, 3, 4, 5, 6, negative 6 over, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's a negative 6/11 slope. That's a little more than a 50% slope, or a negative 1/2, just slightly above that. Okay? Pretty easy. You've had this before, but once again, this is one of those building blocks. You're going to use this for geometry, algebra 2, pre-cal, calculus, everything. Slope does not go away. It's like that annoying cousin that comes for Christmas and just never seems to know when to leave. Our next topic is going to be slope by formula. Now remember from what we just discussed, when we find the slope of each line, we simply count it out. I'm just going to do some examples here. Line D is a no slope. Line B is a 0 slope. Why don't we pause the recording for just a moment and you see if you can figure out line A and C on your own. All right, welcome back. So our slope for line A, I go down 1, 2, and I go over, so that's a negative 2 over 1, 2, 3, 4, 5. So I have a negative 2/5 slope for line A. For line C, I go up 1, 2, 3, and over 1, 2, 3. So for line C, I have a 3/3 slope, which is just simply a perfect slope of 1. So once again, to review, when I had the vertical line, very, very important that I remember this. No slope. The horizontal line, 0 slope. And then so on and so forth. So what if no graph is given? What if you only know 2 points that a line goes through? Oh no! What are we to do? All hope is lost. But alas, Super Math Man comes in with the solution. Find the slope of a line through the points 5, 2, and, whoops, I seem to be moving my tablet too much. There we go. And 8, 7. So if I were to do that, I could do this one of 2 ways. I could recognize that I could draw out a graph on my paper, and if you want to do this for the STAR test, if it floats your boat, that's fine. As long as you pass the STAR test, we're fine with that. Okay? 2, 3, 4, 5, and up 1, 2. There's a point. And over 3 more, and up to 7. And there's my other point. Now notice, though, that if I have rise over run, that's change in y over change in x. That triangle that I just drew is the Greek symbol for delta, which means change. You're going to see it all the time in both math, chemistry, physics, all of the above. So the change in x. So how much is my y value changing first? Let's do change in y, since it's the numerator. Well, it's going from 2 over to 7. which means I have a change in 5. What about my x? Well, I have a 2 going to, or a 5 rather, going to an 8. What's the difference between 5 and 8? Well, that's 3. Now, we just kind of looked at that and we got that our slope is 5 over 3. That's pretty cool. But what does that mean? That means, looking at our next formula here, that the slope is indicated by m, given 2 points, x1, y1, and x2, y2. That basically, if you subtract your 2 y points, your 2 y values, and put it over the x values subtracted in the same order, then basically you'll get your slope. This is an important formula. Pay attention. Put your cell phones down. No texting, tweeting, Instagramming, Facebook, IMing, MySpacing, emailing, telegraphing. This is a very, very important lesson to learn. This formula will be given to you on the STAR test. I can almost guarantee it that they're going to put questions about this formula on the STAR test. Why? Because they've done it before, and if I were them, I would put a formula about this on the STAR test. Okay? So what I do is I look at my points. I'm going to label these. So find the slope of the line through these points. I'm going to label these x1, y1, x2, y2. I look at my formula. I should have like a sound clip of angels singing in the background for the importance of this formula. Okay? Put my y's on top. So my y's are 8 minus 3. My x's are 4 minus negative 2. Now that's pretty easy. The numerator simplifies. But ruh-roh, Raggy, to quote Scooby-Doo, I can't subtract with a negative number. Not that you shouldn't do it. Not that it's not cool not to do it, but it's mathematically incorrect. We just don't do that. So remember what I taught you. Slash and dash. Always slash and dash. So it becomes plus a positive. Instead of minus a negative, it becomes plus a positive. 4 plus a positive 2 is 6. And guess what? We've just found our slope. Not hard at all. Let's practice it again. So my y value, my x, 1, y2, y1. See, even math teachers make mistakes. Contrary to what we tell people, we're not perfect. x2, y2. All right. My y2 is 2 minus negative 6 over my x2, which is negative 5, minus 7. Once again, we've got some convoluted negative numbers, adding, subtracting. It's just icky. So, let's go ahead, slash and dash. Becomes plus a positive and plus a negative. So I get 8 over negative 12. Bring my negative onto the outside, so negative. Let's reduce our fraction, top and bottom by 2. 4 over 6. Can I reduce that more? Absolutely. Negative 2/3. So my slope here is simply negative 2/3. Beautiful. Absolutely beautiful. I want you to try number 3 and 4 on your own. We're going to pause the recording. Try them on your own, then press play when you're ready. And we're back. So, by now what you should have done, let's label them x1 and y1, x2 and y2. 5 minus 1 over 2 minus 2. Aha! We have a little bit of a tricky one here. So I have 4 over 0. That is not a possibility. I cannot divide something by 0. It is mathematically inappropriate, incorrect, and just bad. Just bad. Okay? So 4 divided by 0 becomes no slope. Next, x1, y1, x2, y2. 5 minus 1 over 2 minus 2. And I need to go back to this other problem over here because I realized I made a boo-boo. It happens even to us perfect math teachers. I did my x's on top and my y's on bottom. I'm sorry. So what happens is here basically we flip to get all that erased. So we have all right, 2 minus 2 over 5 minus 1, which gives you 0 over 4, and that is a 0. I erased as I wrote. 0 slope. Over here, however, we get 4 over 0, which gives us the no slope. Okay? So once again, 0 in the numerator, okay, that's a 0 slope. 0 in the denominator, no slope. Once again, not a function. So determine the value of r so that the line through the given points has the indicated slope. So basically, I have my formula, m equals y2 minus y1 over x2 minus x1. So what I'm going to do is I'm going to say 1 over 5 equals, okay, here's my x1, y1, x2, y2. So I have 5 minus 4 over r minus negative 2. Let's simplify that down. So I have 1 over r slash and dash plus 2. So my numerators here and here, they already match up. My denominators here, I need to figure out basically what plus 2 equals 5. If I want you to have $5 and you have $2, how much money am I going to give you? Well, it's a trick question because I'm a school teacher, and school teachers don't get paid enough to give you any money. But let's say I were Donald Trump. I would be giving you then $3. So I would say 5 equals r plus 2, and thus r equals 3. Okay, let's try number 6 over here. Negative 3 over 4 equals, and we're doing x1, y1, x2, y2, r minus 3, and 1 minus negative 1 minus 4. Sorry, wrote those down incorrectly. Negative 1 minus 3 and r minus 4. Let's simplify some things. So negative 3 over 4 equals r minus 4 over negative 4. Now in this case it's not so simple because things are not matching up so perfectly. So what I'm going to do is we're going to cross multiply and divide. We remember this from, I think we learned this in 4th grade. So negative 3 times negative 4 equals 4 times r minus 4. So I get 12 equals, now remember, I've got a distributive problem, so I'm going to distribute my 4 through to everything. 4 times r, and 4 times negative 4 is 16. Let's add 16 to both sides because we're solving for r. So that gives me 28 equals 4r. Divide by 4, r equals 7. So once again, I set it equal to my slope problem. I cross multiply and divide. Simplify according to order of operations, PEMDAS. PEMDAS tells me I've got a parentheses in there, thus I have to distribute first, then after that multiply, add, subtract, etc., etc. All right, at this point, I think it's a great opportunity for the class to go ahead and take a break. Take a 5 to 10 minute break. Be back here within 10 minutes. Do not push it. The sub will tell me if you've been gone too long. Feel free at this time to text on your phones. Move about the cabin. Caution, overhead compartments may have shifted during air flight. Pause recording now, please. And we're back. I trust you had a very restful sleep. Not sleep, I'm sorry. Very restful break. Took care of all of Mother Nature's calls, tweeted and texted so that way you got up on all the drama that was happening. You know, if Kim Kardashian has a new boyfriend, whatever. So in this topic right here, what we're going to do is we're going to graph lines in the y equals mx plus b form. The y equals mx plus b form is something of great importance to us. In fact, we would say it is one of the foundational aspects of all of Algebra 1. In fact, you'll use this Algebra 2, you'll use this in geometry. This is another one of those things that just is those ugly, obnoxious cousins that comes at Christmas and just never knows when to leave. Tries to move in with you. So what we're going to do is we're going to map a point, and then we're going to create a line given the slope. Now, to recap what we learned before the break, slope is rise over run. Slope is rise over run. My change in vertical height, or my change in vertical distance over my change in horizontal distance. So let's graph my point first. Okay? Zoom in here. -3, back 3, 1, 2, 3, and up 1. Now, if the slope is 3, that means it is 3 over 1. Remember, any whole number is simply that over 1 in fraction form. So I'm going to go up 3 and over 1. Up 3 and over 1. This is just to give me, I can do this as many or as little times as I want. I normally like to do it twice so then I can put a ruler, a straight piece of paper down, or just draw my line through more easily. So now, voila, I have drawn my line, and that line is that line going through that point with that slope. Okay, let me try one more over here. So, 5, 2 over 1, 2, 3, 4, 5, up 2. My slope is, bring that down a little bit. Oh boy. Uh-oh. Alright, my slope down 4 and over 3. So I'm going to go from this point right here. I'm going to go down 1, 2, 3, 4, and over 1, 2, 3. I've drawn that. Now I'm going to simply draw a line that goes approximately through the correct point. There we go. And then I just continue it. So what we've just done there is, without actually knowing the equation of the line, with nothing more than a slope and a point, This is like one of those superhero stories of math, you know, like MacGyver. He only had, I don't know if any of you remember that television show, he only had a stick of chewing gum and a paper clip and a rubber band and an old car, and he made it into a nuclear bomb or something. With only a few little insignificant little pieces, we created a masterpiece. Voila. What I would like you to do is press pause on the recording, and I would like you for a moment, oh boy, come back here, come back. If I can get back, there we are. I would like you to graph these two, number 3 and number 4, on our work. So press pause now. And we're back. So let's see how you did. Let's compare it to Mr. Rhodes. So let's walk you through this. Back 3, 1, 2, 3, and down 1, 2, 3, 4, 5. There's my point. Now I have negative 4. Remember, that's negative 4 over 1. So I go down 4, 1, 2, 3, 4, and over 1. So there's my new point. There's my line. It helps if you have a ruler. Now, what I can do, show you a little trick, is I know that from here to here, it was a difference of 4 and 1, so I'll do the same thing, just in reverse. That puts me with a point up there. Straight line. And continue that on. Approximately so. Over here, 2 comma negative 4 over 2. 1, 2, 3, 4. Slope of up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Excellent. Draw that out like so. Give it a tail on this side. And to be correct, let's go ahead and put our little arrows on here. And that tells us now I've just graphed my point. Now notice it's extremely important for us that we have this graphing system down. It helps us because let me tell you something. On the STAR test, there are going to be questions that say which is the correct graphing of these points, which is the correct graphing of this equation, which of these graphs is not accurate, which of these is not like the other. They're going to ask questions and questions and questions about graphing because that's all a part of Algebra 1. So this is very important for us to grasp. Okay? So let's go on to the next page. So in large triangle ABC, to create a triangle with sides that are twice as long, use vertex A as the vertex of the larger triangle. What are the new coordinates of the new triangle? Now, what they're basically wanting you to do to go twice as long, what you're going to do here is you're going to go and you're going to figure out what is the slope, and then you're going to double the slope for each of these. That's basically what they're doing. What's cool is this is a algebraic geometry type project. Promise you, you get to my class next year teaching geometry, bada bing, bada boom. You're going to have something like this. It's going to be beautiful. Okay? So on this first one, let's zoom in here. I'm going from A to C, or let's go from A to B. I go 1, 2, 3, and 2. So I go up 3 and over 2. So now, to go up 3 and over 2 from there, instead I'm going to go up 6 because it wants me to twice as long. Thus, I'm going to double it. So I'm going to go up, instead of that, I'm going to go up 6. So that's 3, 4, 5, 6. And I'm going to go over 4. 1, 2, 3, 4. And there's my new B coordinate. So my B coordinate is 1, 2, 3, 4, negative 4. Write my ordered pair down here. And up 1, 2, 3, 4, 5, 6, 7. Now for C, it was up 1 and over 3. So now I'm going to go up 2, 1, 2, and over, oh boy, over 1, 2, 3, 4, 5, 6. And that gets me my new C coordinate. We'll call this C prime and B prime. Notice on here the little asterisk. that's next to each of these. When I change a point, when I'm dealing with any type of coordinate system, and I alter a point, I transform it is the correct term. I transform the point, thus I indicate it by writing the original point name, such as A, B, C, or D, with an apostrophe, and thus it becomes B prime, C prime, etc., etc. I suppose if you had a point named Optimus, and you transformed it, it would be Optimus Prime. It's kind of cool to think about. For those of you that like the Transformers, if you don't, then we need to talk about your taste in everything. So, back 2, so that's negative 2, the ordered pair for this point, and up 1, 2, 3. So thus, this is my ordered pair. Awesome. Now, it wants me to then enlarge XYZ to create a triangle with sides 3 times as long. Use X as the vertex. It is the point from which all of this flows. So why don't we press pause and you give it a go. And we're back. So the change, my slope, from X to, let's do X to Z, was over 1, 2, 3 to the left, and down 1, 2. Okay, so let's go. We want it 3 times as large, so I need to do 9 to the left. If it was 3 to the left, I'm going to write it down here under Z, and 2 down. That means I need to go 9 left and 6 down. Now remember, 9 left is basically X minus 9. Whatever my X coordinate is, minus 9. And 6 down is basically my Y coordinate, minus 6. So instead of counting all these out, because if you notice, the Y coordinate is going to go off the grid, and we're going to have some problem because I don't have enough grid for it. But what I can do is find what is the ordered pair and then do some basic arithmetic. So the ordered pair for Z is over 1, 2, 3, and up 2. So I'm going to subtract 9 and subtract 6. So my new pair, 3 minus 6, 3 minus negative 9 is negative 6. 2 minus negative 6 is negative 4. So my new one is negative 6 comma negative 4. Looking at Y. Y was down 1 over 1. Awesome. So Y was 1. Let's see here. Y was 1 to the right. And it was 1 down. I like 1. It's an easy number to deal with. So I go 1 right, so that's adding 1 to X, and 1 down is subtracting 1 to Y. But notice I'm doing it 3 times larger, so it becomes X plus 3 and Y minus 3. So my my coordinate for Y was over 1, 2, 3, 4, 5, 6, 7. So Y was 7, comma, up 1, 2, 3. So I'm going to add 3 and subtract 3. Okay, and that gets me 10, comma, 0. So my coordinate for Y prime is 10, comma, 0. Kind of a convoluted way of trying to get it done, but it works. Okay? Let's quickly move forward here. Oh boy, I went way too far. Come back. Baby, come back. Where am I at here? Okay. So state the slope The graph of the equation y equals mx b, not blee, is a line whose slope is m and the y-intercept is b. So the y-intercept, the slope is 2 here, and the y-intercept is 4. Basically, slope is your rise over run, as we discussed, and b is basically your y-intercept. It is the place where your line crosses through this y-axis. I'm shading it red. So the first thing I'm going to do, if I have a graph like so, and I'm trying to graph it, and they've given me the y-intercept, I'm going to go to my y-intercept, which is up 1, 2, 3, 4. So it is right there. And I'm going to basically just graph it out. Up 2 and over 1. Up 2 and over 1. Up 2 and over 1. So what I've done here is I've created a line based on the y-intercept and the slope. Let's try it again over here. B, my y-intercept was -3. My slope, -3/2. Okay, so I go down 3, 1, 2, 3. There is my y-intercept right there. So I go down 3, 1, 2, 3, and over 2. And down 3 and over 2. So basically, I draw my line then through the points that I have created. Like so. All right? So, this is interesting. Number 7 here. Very, very interesting. Y equals 4 minus x. So I look at what's in front of the x. That's -4. That's my slope. But there's nothing there after it. There's nothing there after it. What am I supposed to do? Simply going to write a 0. Because if there's nothing there, there's nothing there. What am I supposed to do? Create a y-intercept out of thin air? No. They've given me a y-intercept. It's simply plus 0. So I start at the origin, 0, 0, and I go down 4 and over 1. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. Like so. All right? Look at the one on the right. You try graphing it. We'll press pause and graph it. Go. All right, welcome back. So go down 1, 2, 3, 4 for my y-intercept, -4. My slope, 5 over 3. So I go up 5, 1, 2, 3, 4, 5, and over to the right, 1, 2, 3. And I get a line like so. All right, now topic 6-7, we're almost to the end, I promise, we're getting there. We're talking about then taking it from whatever form it's in and getting it to y equals mx plus b. Because what you haven't done today is you have not used a calculator to do any of this graphing. But what's cool is our TI graphing calculators have this capability that you can input, as you've done before, you've done it in Algebra 1, input the formula, and then it'll graph it for you. But the thing is, it needs to be into y equals mx plus b format. So what I basically want to do is notice over here, y is by itself. I'm isolating y. Y has been a very bad boy and needs to have timeout, get away from everybody else. So what do I need to do to isolate y in the first problem? To isolate y, I need to subtract x from both sides. So I have y equals 3 minus x. Now notice, I want this in the easiest possible format so that I can eyeball it and be done. So I'm going to bring this right here, I'm going to switch them. Remember, we talked about the commutative property of addition and subtraction, or of addition simply states that I can rearrange things accordingly. So y equals negative x plus 3. Now this becomes a lot easier to graph. Y-intercept and slope. So my y-intercept, I go up 3, and I'm simply going down 1 and over 1. Down 1 and over 1, down 1 and over 1, down 1 and over 1, so on and so forth. Draw my line through, and I'm done. This one right here, let's subtract our 3x from both sides. Subtract 3x, subtract 3x. So I have negative y equals negative 6 minus 3x. But what do I notice is left here with my y? Oh, why must this be so difficult? My negative number is left. I have a negative y. My format up at the top doesn't say negative y equals mx plus b. It says positive y. So I have to change this. So to undo the negative, we simply multiply both sides by negative 1. So we basically change everybody's signs, and I have 6 plus 3x. Everybody's positive and happy. Y equals, rewrite it, 3x plus 6. So I'm going to go to 6 on my number line, or my y-intercept, my y-axis. 1, 2, 3, 4, 5, 6. I go up at this point, that's where I'm starting at. I go up 1, 2, 3, and over 1. And I can draw a line like so. Want you to try this one on your own. This is a multiple step one. Similar to what we did before, except hint, hint, you're going to use division somewhere in here. Press pause. All right, let's go through it. Subtract 2x from both sides. And I get negative 3y equals negative 2x minus 9. The next thing I'm going to do is divide everything by negative 3 to solve for y. Divide by negative 3. Divide by negative 3. Notice my negatives cancel out, so I have 2 over 3x plus 9 divided by 3 is 3. Graph this bad boy out on here. Bad boys, what you gonna do? Never mind. All right, go up 3. 1, 2, 3. And then that is my y-intercept. From there, I go up 2 and over 1, 2, 3. Up 2 and over 3. Up 2 and over 3, since that takes us right to the corner. Boom, just like that. All right, let's move forward. Very interesting problem here. Very interesting problem. Very, very, very interesting. So to solve for y, I'm going to divide everything by 3. That's very easy. So I have y equals 2x. So do I have a y-intercept here? Well, some people would say, no, I don't. But yes, I do. It's simply 0. So I start here in the origin, which is 0, 0. Remember, we learned the name of the origin yesterday, at the same time as we learned x-axis, y-axis, etc., etc. And I'm going to go up 1, 2, and over 1. 1, 2, and over 1. 1, 2, and over 1. Problem solved. We're good to go. Next, which of these ordered pairs are solutions of each equation. Basically, what you're going to end up doing here is you're going to plug in any of these numbers and see if it all comes out right. So, I have 2x minus 5y equals 1. So let's look if negative 7 and negative 3 work. So I go 2 times negative 7 minus 5 times negative 3. And if this is correct, if it is a solution, I need that to equal 1. So I get negative 14 plus 15. And that equals 1, equals positive 1. So therefore, yes, because this is the same as that right there, yes, I do have the appropriate proper solution. Let's take a look at one that wouldn't have worked, 7 and 3. 2, comma, or 2 times 7 minus 5 times 3. I would have 14 minus 15. That would get me negative 1. So because negative 1 here does not equal 1, therefore, that simply does not work. All right, let's see if any of the rest of these happen to work out. You never know what these tricky little math teachers will do. All right, 2 times 2 minus 5 times 1. You have 4 minus 5. Well, that equals negative 1. That's a no-no. That's a no-no. Bingo. Let's try the last one. 2 times negative 2 minus 5 times negative 1. So I get negative 4 plus 5. That equals 1. This is also a solution. So these two ordered pairs were solutions of the equation because when I plugged them in, they added up and multiplied to the right number. It made sense. We got after this one. You go ahead and try number 6 on your own. Press pause, please. And we're back. So we're going to plug each of these in. 3 times 1 plus 2 times 3 gives me 3 plus 6, which equals 9. That's a no-no. Next, 3 and 1. So 3 times 3 plus 2 times 1. That gives me 9 plus 2 equals 11. Hey, I like that one. That one works. 11 equals 11. Let's try 5 and negative 2. 3 times 5 plus 2 times negative 2. Gives me 15 minus 4. That gives me 11. Hey, this one works too. Let's try negative 1 and 4. So 3 times negative 1 plus 2 times 4. Negative 3 plus 8. Thank you. Sorry, wrong answer. You are disqualified. There used to be an old game show and they'd say, "You are the weakest link. Goodbye." So that one was the weakest link. Goodbye to it. Okay? Let's move forward here. Looks like a blank page got entered in here. All right. We come to our last topic worksheet, and then after that, we'll kindly see if you can take a break. Interpret the graph. You know, it's not just so much that we know how to write these graphs. It's not just so much that we can plot them, draw a line, connect the dots. Anybody can really do that. But what takes a higher level of thinking is to look at a graph and to sort of make it talk to you. So on line A, what is the value of y when x equals 2? So I look at this line right here. I look at that line right there. And I'm looking for when x equals 2, which is right here. And I just simply go up. And it's 1, 2, 3, 4, 5, 6, 7. All right? So you kind of see what we're doing there. I want to see, let's press pause and see if you can do 2 through, let's just see you do 2 through 11 on your own. If you don't get 6 and 11, that's fine. Skip over them. Don't spend a lot of time on them. We'll practice those when we get back. So go ahead, press pause. All right, and we're back. So what is the value of x when y equals 6 on line A? So when y equals 6, so I go up to 1, 2, 3, 4, 5, 6. That happens to be my y-intercept. So x is going to be 0. When x equals negative 8, so let's go on line A. 1, 2, 3, 4, 5, 6, 7, 8. And it's up 1, 2. It's positive 2. So what is the slope of line A? Well, the slope of line A, you go up 1. Just look from point to point. So I'm going up 1 and over 2. 1 and over 2. What is the y-intercept of A? Where does it cross the y-axis at? We already said that was at the point 6. So the equation of it is, if the slope is 1/2, so that's y equals, over here to the side, y equals mx plus b. So my slope is m, my slope is 1/2, and my b is 6. So y equals 1/2 x plus 6. Now, on line B, what is the value of x, or of y, when x equals 1? Well, on this line over here, at 1, I go down 1, 2, 3, so it is negative 3. What is the value of y when x equals negative 3? So when x equals negative 3, I go back 1, 2, 3. It goes up 1, 2, 3, 4, 5. What is the slope of the line? Well, the slope, let's just pick these 2 points right here. You go down 1, 2, and over 1. Negative 2 over 1, or negative 2. What is the y-intercept of line B? Well, it crosses the axis right here at negative 1. So the equation, my m is negative 2, my b is negative 1. So y equals negative 2x minus 1. Pretty easy. Okay? Last page. The end is near. The end is near. All right. If 4 comma y is a solution to this equation, what is the value of y? So what they're basically saying is, we'll give you the x coordinate, we've given you the equation, now solve for y. This is easy. You guys have been doing this all week and all year. So let's plug it in, plug it in. Remember the Glade commercial. 3 times 4 plus 2 times y equals 4. 12 plus 2y equals 4. Remember, I want to isolate the y. Before I can do that, let's subtract 12 from both sides. So 2y equals negative 8. Divide by 2, y equals negative 4. So when x equals 4, in the equation 3x plus 2y equals 4, y equals negative 4. All right? Now, graph the equation 3x plus 2y equals 8. Remember, in order to graph something, I want this in my y equals mx plus b format. I don't want it in anything else, so let's get it over there. So let's rewrite this, plus 2y equals 8. Let's subtract 3x from both sides. So I get 2y equals negative 3x plus 8. Let's divide by 2. So y equals negative 3 halves plus 4. Now that I can deal with. So my y-intercept, first thing I'm going to graph, I'm going to go up 1, 2, 3, 4. Next, I'm going to go down 1, 2, 3, and over 1, 2. And let's draw on another point, 1, 2, 3, and over 2. And voila. Graph the line x equals negative 7. So basically, this line, this is a unique kind of line. What we're graphing here are all the values of x equals negative 7. So what are all the values for x equals negative 7? So let's go over to negative 7. 1, 2, 3, 4, 5, 6, 7. And what I simply do when I have an x equals negative 7, I draw a line straight through. All the way through. And that is my line, x equals negative 7. Basically, it covers every value on the coordinate plane where the x value is negative 7. All right? And finally, determine the value of r so that the line through the given points has the indicated slope. Oh, that is a tricky one. All right, has the indicated slope through those 2 points, 5 comma negative 6 and r comma 6. Okay, so the change between the two in terms of vertical and the change in the two in terms of horizontal. All right, so before I do that, let's get the equation of my line. Let me show you the basic way of how we're going to do this. So if y equals mx plus b, they've given me the slope, y equals negative 2/3 x plus b. I need to solve for b so I can get the y-intercept, so that I have the full equation. So they've given me one ordered point right here. So I have negative 6 equals negative 2/3 times 5 plus b. So I have negative 6 equals negative 10 over 3 plus b. I'm going to add 10/3 to both sides to get rid of it. Now before I can do anything, I need to combine like terms. And before I can do that, I need a common denominator. My common denominator is going to be 3, so I'm going to transfer negative 6 and convert it into an improper fraction. So that's going to become negative 18 over 3 plus 10 over 3, and all that equals b. So b will equal negative 8 over 3. So my actual equation is going to be y equals negative 2 over 3x minus 8 over 3. Now, I'm going to come over here then to this point, r comma negative 6. They've given me the y value. So 6 equals some value for x, I don't know what that is, minus 8 over 3. So I'm going to add that to both sides to get rid of it. Once again, I need to get this to a improper fraction with a common denominator. So I have 8 over 3 plus 18 over 3 equals negative 2 over 3x. 26 over 3 equals negative 2 over 3x. Now, remember, in order to get rid of a fraction, I multiply by the reciprocal, which means numerator becomes denominator and denominator becomes numerator. So negative 3 over 2. My 3's are going to cancel. So I end up having negative 26 over 2 equals x. And that simplifies to negative 13 equals x. So now my value, my point, where r comma 6, it's actually negative 13 comma 6. And there you have today's lesson. At this time, the teacher in the classroom will pass out the practice problems. If the teacher so decides, you may take a break of about 5 minutes, no more, certainly no less. For that, please come back and work on these practice problems. If you have any questions, feel free to save them until I return on Monday.